Today we're going to go over L'Hopital's rule and its uses. Just note, this video will not include a proof of L'Hopital's rule, so just wanted to make that clear. So what is L'Hopital's rule? Well, it states that if we have a limit x going to c of f of x divided by g of x, this equals the limit of x going to c of f prime of x, the derivative of fx, over g prime of x, which is the derivative of gx. Now this rule is very useful when we're trying to solve limits, and direct substitution gives us like an indeterminate function, like divide by 0, divide by infinity, such as functions like that. So some cases where it's useful is if we have a function like this, limit x to going to 0, sine x over x. Let's call this problem A. If we have a function like this, and we can try direct substitution, well, we would get sine 0 over 0. And we know sine 0 is just 0, so we'd get 0 over 0. This is indeterminate. But using this rule, we can find the limit. So, limit x to 0 sine x over x is actually equal to limit x to 0. And we know that the derivative of sine of x is cosine of x. So, cosine of x over 1. We know cosine of 0. Now we can use direct substitution. So we know cosine of 0 over 1, and cosine of 0 is 1, so we just get 1 over 1 is 1. So through using this rule, we have found the derivative of this, whereas using direct substitution, not the derivative, sorry, the limit of this, whereas using direct substitution would give us an indeterminate function. We can do this in other cases too, such as problem B. We have something like a limit x going to 1 of 5x to the 4th minus 4x squared minus 1 over 10 minus x minus 9x cubed. Now, if we just plugged x in, we would get 5 minus 4 minus 1 over 10 minus 1 minus 9. This again gives us a 0 divided by 0 error. Now, using the same rule, we can do limit x going to 1, 5x4 minus 4x squared minus 1 over 10 minus x minus 9x cubed. So, find the derivative. So, limit x going to 1 is equal to this would be 20x cubed minus 8x, and since 1 is a constant, it would be minus 0. And so again, constant, so that would be minus 1 minus 9x squared. Now we can try direct substitution and see if it works. So this would give us, if we just substituted it, we go 20 minus 8 over negative 1 minus 9, which equals 12 over negative 10. So we have found the limit that this goes to is actually negative 6 over 5. L'Hopital's rule also works if we have a function that where the limit is going to infinity. Something such as limit x going to infinity of e of x, Euler's number, over x squared. If we tried direct substitution, we would get e to infinity over infinity squared. This obviously you can't square infinity or raise e to the power of infinity, so this would give us another indeterminate function. This would just give us infinity over infinity, as both are getting increasingly larger. But if we use the rule again, so we would get limit x to infinity e to the x over x squared is limit x to infinity, and the derivative of e to the x is just itself, so e to the x over 2x. Now, if we try direct substitution, we would still get e to infinity over 2 times infinity, which would again give us an indeterminate function, infinity over infinity. But we can use the rule multiple times, as many times as needed. So if we use the rule on this again, we would get limit x to infinity e to the x over 2x is equal to limit x to the infinity, e to the x is itself again, and then this is over 2. Now, we would get something where we have shown that e to the x is increasing at a much faster rate than x squared is. So if we take the limit of this, it would just be infinity. Because e to the x is just constantly increasing, and it doesn't matter if you divide by 2, it's always increasing, so this is infinity. So you can use L'Hopital's rule as many times as is needed to find the limit of a function. So this is just some simple cases where L'Hopital's rule is useful.